Hi again. Welcome to Chapter 6.3, Pressure and Volume, and this includes Boyle's Law. Okay, if there is a change that occurs in opposite directions, the properties are said to have an inverse relationship. Okay, and so if we have a change in one property and it causes a change in another, then we can categorize these relationships as inverse or as direct relationships. Boyle's law states that pressure and volume have an inverse relationship as long as the temperature and the amount of gas are held constant. Okay, so the volume and the pressure are inversely related, so if the volume decreases, then the pressure is going to increase, and vice versa. So if the volume increases, then the pressure is going to decrease. So if you look at this example here, we have a volume of 4 liters. Okay, if we half this volume to 2 liters, then the pressure is going to double. Okay, so they have an inverse relationship. And remember that pressure is force per area. Okay, and so there's more force being exerted on this second container here because the gas molecules are striking the container harder and faster and with more force when the volume is decreased. So Boyle's law can be stated as P1V1 equals P2V2 if temperature and N, or number of moles, are held constant. So we have, there's an example of Boyle's law that hopefully you're doing right now as we speak, and you would be breathing. Okay, and so during inhalation, the lungs expand. Okay, so the volume increases. And so the pressure in the lungs actually decreases. And this is what causes your diaphragm to contract and move down. And air flows towards the lower pressure in the lungs. When you exhale, the lung volume decreases, and so the pressure within the lungs is going to increase, and the airflow is going to move from the high pressure in the lungs to the outside. So this is where your air is exhaled, and the rib cage gets smaller as these rib muscles relax. Okay, our equation for Boyle's law, P1V1 equals P2V2. We can rearrange this equation and solve for any of the 4 variables as long as we have the 3 of the 4 variables. So we can rearrange if we were looking for V2, then it's a simple just rearrangement, and you can divide both sides by P2 to solve for V2. So when we use the Boyle's law in calculations, we want to organize the data in a table, or just organize it however you would like, for initial and final conditions. So the P1 is for initial, so you can even think of it as PIVI for initial, and P2 or PF for final. So 2 is the final. Then you rearrange the gas law to solve for the unknown quantity that you're looking for, and then you substitute the values in the gas law, and then you calculate. Okay, so Freon 12 is used in refrigeration systems. What is the new volume? Okay, so we're going to be looking for V2 of an 8-liter sample of Freon. So 8 liters is our V1. So you can see that down at the bottom of the screen. Initially at 550 millimeters mercury. Millimeters mercury, that is our units for pressure. Okay, and so that's our P1 because initially that's what the pressure is. And then we're going to change the pressure to 2200 millimeters mercury at constant T and N. Okay, and so the change, P2, is 220. So you can set this up and you can organize the data as so, or however you would like. One of the most common mistakes is accidentally putting V1 where you should have had V2, or P1 where you should have had P2. So be sure you get them organized correctly. Okay, when the pressure increases, the volume decreases. So we know that that's going to happen, okay, but we want to know by how much. So if we rearrange our Boyle's law here in step 2, we see that V2 is equal to V1 times P1 over P2. So we just divide through by P2 on both sides. Okay, and now we can just substitute the values in. So we said that V1 was 8, P1 was 550, and then we divide by 2200 because that's our P2. And we get 2 liters, which is what we just expect. We would expect the volume to decrease. Okay, let's work this one out now. So a sample of oxygen gas has a volume of 12 liters at 600 millimeters mercury. What is the new pressure when the volume changes to 36.0 liters at constant T and N? Okay, so we want to set up and organize our data. A lot of times once you get a hang of it, I just kind of go through and label each. Okay, so we're looking for the new pressure. So we're looking for P2. The sample of gas has a volume of 12.0 liters, so that's our V1. At 600 millimeters mercury, that's our P1. We're looking for P2, and we're changing the volume, so that's what's being changed here. So we're changing the volume, so that's our V2. Okay, and you can go ahead and kind of make an assumption because we know the law, what the law states now. And so now we have an increase in volume. Okay, so we should expect a decrease in pressure. Okay, so if we write out our law, P1V1 equals P2V2. Okay, we're looking for P2. Okay, so if we rearrange and we isolate P2 by itself, we get P2 equals P1 times V1 divided by V2. Our P1 is 600 millimeters mercury. Our V1 is 12 liters divided by 36 liters. That is our V2. And we should get 200 millimeters mercury, which makes sense because we would expect the volume to decrease when the, we would expect the pressure to decrease when the volume increases. You also want to watch the videos I have posted on Blackboard that are showing just some experiments. I think most of them are YouTube videos, but they will help you kind of see these laws in practice in an experiment. This concludes the video on Boyle's Law.